Hello students, welcome to a series of mathematics program for grade 10 and grade 11. The topic for today is matrices. This is the third lesson on the chapter matrices. So let us start. You will remember that in the previous lessons, you had learned what is a matrix, how to display information in the form of a matrix of any order, how to solve problems involving addition and subtraction of matrices where possible, and interpret the results, how to calculate the product of a matrix and a scalar, and how to find the product of two matrices. In today's lesson, you will learn how to use the algebra of 2 by 2 matrices, including the zero and identity 2 by 2 matrices. You will also learn how to calculate the determinant and inverse of a non-singular matrix A. Now, before we proceed further, let us have a quick recap of what is a zero matrix and what is an identity matrix. You will remember that a zero matrix is a square matrix with all its elements equal to 0. It will be a square matrix and all its entries will be equal to 0. Now, for an identity matrix, again, it will be a square matrix where the leading diagonal will consist only of 1 as element. All the elements in the leading diagonal will be equal to 1, and the remaining elements will be equal to 0. The remaining elements will be equal to 0. But here we are going to consider only 2 by 2 matrices. We first start with solving matrix equations. A matrix equation is an equation where we have an unknown matrix. Let us consider this example. I need to find the unknown matrix X, where X plus minus 1, 8, 4 minus 5 equal to 2, 7, 6, 3. Now, let us consider a simple algebraic equation, linear equation. Suppose you have X plus 2 equal to 5. How do you solve this equation? X plus 2 equal to 5. X will be equal to 5 minus 2, which is 3. What I have done is send the 2 on the other side. That is, we call it the additive inverse. We send the 2 on the other side. That is, we have 5 minus 2. So here we are going to proceed in the same way. I need to send this matrix on the other side. So I have plus here. When I send it to the other side, I will get minus. Now remember, we can only add or subtract two matrices if they are of the same order. So here, both these matrices are of order 2 by 2. And I know that the matrix X will also be of order 2 by 2. Now, to subtract these two matrices, I subtract the corresponding entries, the corresponding elements. So here I will have 2 minus 1, which is 3, 7 minus 8, which is negative 1, 6 minus 4, which is 2, and 3 minus 5, that is 3 plus 5, which is 8. Second example, solve the following matrix equations. So here we have two parts. Let us have a look at the first part. So I have a 3 by 2 matrix here, 3 by 2 matrix here as well. So I know my answer, the unknown matrix A, will be a 3 by 2. matrix. So 2a will be 9 minus 5 minus 1, 0, minus 6, 8, minus this matrix. So I will have minus 3, 0, minus 4, 5, 6, minus 7. So matrix 2a will be equal to, we subtract the corresponding entries, 6, negative 5, 3, negative 5, negative 12, 15. Now to find matrix A, I need to divide each and every element found here by 2, or I can also multiply each and every element found here by half. So matrix A will finally be equal to 3, negative 2.5, 1.5, negative 2.5, negative 6, and 7.5. I divide each and every element found here by 2, or like I've said, we multiply by half. Part B now. So you have a 2 by 2 matrix here, you have a 2 by 2 matrix here. You know that your answer B will be a 2 by 2 matrix. Okay, because we have subtraction, we are dealing with addition and subtraction, so the order will stay the same. I will have minus 1/4 B equal to this matrix, 5, 3, 1, 8, minus this matrix, 2, 5, 6, 3. So minus 1/4 B will be equal to 3, negative 2, negative 5, 5. Now to get B, the matrix B, I multiply all the elements found here by negative 4. So you're having a scalar multiplication. You multiply all the elements by negative 4. So you get negative 12, 8, 20, and negative 20. This is quite simple. We now move on to the inverse of a 2 by 2 matrix. So this is something new which you haven't done in grade 9. Consider this 2 by 2 matrix A, B, C, D. Now, before finding the inverse of a 2 by 2 matrix, we are going to look at some other concepts. So first, the determinant of a matrix. So the determinant of a matrix A, usually denoted by this modulus A, which we call determinant A, is given by A times D minus B times C. So determinant of A will be equal to A times D minus B times C. Let us have a look at these examples. I need to find the determinant of each of the following. So part A, determinant of A will be 2 times 5 minus 1 times 4, which is 10 minus 4 equal to 6. Part B now, I need to find the determinant of matrix B, which is minus 1 times 4 minus 0 times 3, which will give me minus 4 minus 0, which is equal to minus 4. Part C, determinant of matrix C will be 8 times 2 minus 6 times negative 1. So here I will get 16 minus minus 6. Remember, minus minus is plus. So the answer is 22. Part D, determinant of matrix D will be minus 7 times 3 minus 2 times minus 1. I will get minus 21 minus 2. Remember, minus times minus is plus. So the final answer will be negative 23. So it's quite easy to calculate the determinant of a matrix. Now note, if you have matrix A with elements A, B, C, D, and if the determinant of A is equal to 0, we say that matrix A is a singular matrix. I repeat, a matrix is said to be singular if its determinant is equal to 0. Consider this example. You have matrix X here with elements 4, -2, 6, -3. So the determinant of X will be 4 times -3 minus 6 times -2, which gives you -12 minus -12, which is 0. So we say that X is a singular matrix. Next example. The determinant of matrix X is 6, where X is given here, and you need to find the value of A. So this is your matrix X. The determinant has already been given as 6. How do you find the determinant? Minus 2 times 4 minus A times 1, which is equal to 6. So you have minus 8 minus A equal to 6. So minus A will be 6 plus 8, which is 14. And A will be equal to -14. Now we move on to adjoint of a matrix. So we again consider the 2 by 2 matrix A, B, C, D. Now the adjoint of a matrix is usually denoted by this ADJ bracket A is given by, so these two we are going to swap. You interchange these two. AD will become DA. I repeat, you swap the two entries here, A and D. They will become D and A. And these two elements, you change the sign. If it is plus, it becomes minus. If it is minus, it becomes plus. Let us have a look at this example. Find the adjoint of each of the following. So part A, these two will interchange places, and these two will change sign. If they are positive, they become negative. If they are negative, they will become positive. So adjoint of A, these two have swapped places, and these two become -1, -4. Adjoint of B, again, these two will swap places, and these two will change sign. So adjoint of B will be 9, -1, these two have swapped. Here, -3 will become 3, and 2 will become -2. Quite simple. But C now, adjoint of C will be 2, 6, 1, 8. Can you try for part D? What will be the adjoint of matrix D? Yes, matrix D will have as adjoint 0, -4, 2, -5. So we have learned first how to find the determinant of a matrix. Second, how to find the adjoint of a matrix. Now we are going to use both determinant and adjoint to find the inverse of a matrix. So we again consider the matrix A with entries A, B, C, D. The inverse of matrix A, denoted by A inverse, is given by, so A inverse is 1 over determinant of A times the adjoint of matrix A. I repeat, 1 over determinant of A times the adjoint of matrix A. So determinant is A times D minus B times C. You will have 1 over AD minus BC. Adjoint means these two will interchange places. These two will change sign. Look at this example. Find the inverse of each of the following. So we have 4 parts. We need to find the inverse. Part A. So first I need to find the determinant. Now, you need to be careful. If ever the determinant is equal to 0, earlier we said that the matrix is called a singular matrix. Now, if the determinant is equal to 0, this means that the inverse does not exist. Why? Because we have for inverse 1 over determinant times adjoint. So if the determinant is 0, I cannot divide by 0. I cannot have 1 over 0. We never divide by 0. So for singular matrices, inverse will not exist. This is why in the learning outcome at the beginning of the lesson, it was mentioned, find the inverse of non-singular matrix A. Only when the matrix is non-singular that you can find the inverse. So we move on with this solution. First, I need to find the determinant. So determinant of matrix A will be minus 1 times 5 minus 0 times 3, which will give me minus 5. Next, I find the adjoint of matrix A. So these two will change place. These two will change sign. And A inverse will be 1 over determinant, which is minus 5, times the adjoint. So here's the adjoint. You can leave your answer as it is, or you can simplify. That is, you multiply all these elements by minus 1 over 5 to obtain minus 1, 0, 3/5, and 1/5. Part B now. You have 2, -4, 9, -1. So first I need to find the determinant. The determinant will be 2 times -1 minus 4 times 9, which gives me minus 2 plus 36, which is 34. Next, I need to find the adjoint of matrix B. So these two will interchange place. I need to swap. And these two will change sign. They stay where they are. They only change sign. To find B inverse, I will have 1 over determinant, that is 34, times the adjoint of matrix B. So finally, I get minus 1 over 34, 2 over 17, reducing to lowest terms, and minus 9 over 34, and finally 1 over 17. So you reduce the fractions to lowest terms. Part C. First, I need to find the determinant, which is 6 minus 6, which will give me 12. Next, I find the adjoint of matrix C. And finally, C inverse will be 1 over determinant times the adjoint, which will give me 1 over 12 minus 1 over 6, 1/4 and half. Now, can you try to do part D? I'm sure you have now understood how to proceed. So let us try to complete part D. First, you need to find the determinant of matrix D, which is minus 5 times 0 minus 4 times minus 2, which gives you 8. Next, you need to find adjoint of matrix D. And finally, D inverse will be 1 over determinant times adjoint. Simplifying will give me 0 minus half, 1/4, and minus 5 over 8. So now you have some questions to practice on what you have just learned. That is solving matrix equations and finding the inverse of a matrix. For example, here you have question 5. The determinant of A is given as 2. So you need to find the value of P, and then you need to find A inverse. Question 6 as well, you have been given the determinant as -4. You need to find the value of K and then find M inverse. Question 8 will be on matrix equations. You also have some links where you can get additional information on how to find the determinant of a matrix, how to find the inverse of a matrix, and how to solve the matrix equations. So in today's lesson, you have learned how to use 2x2 matrices, including the zero and identity 2x2 matrices, as well as calculate the determinant and inverse of a non-singular matrix A. So students, we have reached the end of the third lesson on matrices. Until we meet again for the last lesson on matrices, it's goodbye from me. Thank you for your attention.